This right here is the DEEBOT T50 Max Pro Omni from ECOVACS, their latest flagship that packs a massive punch in terms of suction power. But this video will be a bit different. Usually I do straight to the point, in-depth tech reviews, but this time let's actually focus on the technical aspects that allow this device to create such a strong suction power of 18.5 thousand PA, which is 4 to 5 times more than regular robot vacuums. It is actually crazy. New drip. So let's dive deep into a topic that's been on the mind of many, if not all, robot vacuum enthusiasts, namely suction power. If you've been following the evolution of robotic vacuums over the past few years, you've probably noticed a steady increase in suction power from each to each model. I remember reviewing a robot vacuum a few years ago, and at that time it had a suction power of just 4000 PA. Now fast forward 3 years, and the latest models that we're testing now boast up to 18,000 PA of suction power. And that is 4.5 times more suction than the vacuums from just a few years ago. So what is going on here? Now, many brands out there like to advertise higher suction power as a clear indicator of better cleaning performance. But is it really that simple? Does more suction power actually also always lead to better cleaning? Well, as much as we'd like to believe that suction is the be-all and end-all of robot vacuum performance, physics doesn't quite work that way. Today in this video, I'm going to break it all down for you, how suction is generated, what factors truly influence cleaning performance, and what you really need to know when it comes to choosing the right robot vacuum for you. So stick with me, and by the end, I hope you will have a much clearer understanding of these little but powerful cleaning machines. Alright, before we can dive into suction power, let's first of all take a moment to understand how suction is generated in the first place. It all starts with a basic principle of physics, and you may even recall it from science class. Air pressure in our environment is around 101 kPa. That is standard atmospheric pressure at sea level. If you haven't heard this before, then no worries, now you know. Now imagine you have a pipe with a fan inside. When the fan is activated, it pulls air out of the pipe, creating a lower pressure inside of the pipe compared to the outside. For example, if the internal pressure drops to just 98 kPa, you get a pressure difference between the inside and the outside of the pipe. And this pressure difference is often referred to as vacuum pressure, and it simply creates airflow, always from the higher pressure to the lower pressure, just like a vacuum cleaner sucking in air and debris. And that's also the basic principle that powers every vacuum, whether it's a handheld one or a robotic one. The stronger the fan, the greater the pressure difference, which leads to better, faster and stronger airflow, and also potentially better cleaning. Now let's take that idea and apply it to a robot vacuum. A typical robot vacuum has a HEPA filter in front of the fan to trap dust and debris, as well as a dustbin where all the junk gets collected. There is also a roller brush at the intake right here that agitates or lifts up the dust and debris from the surface so that it's easier for the vacuum to suck it up. And this is where things get interesting, because manufacturers, they often advise the suction power of these vacuums, which is usually given in PA or pascals. For instance, a robot vacuum may advertise that it has a cleaning power of 15,000 PA, but this number, it just represents the difference of pressure inside of the vacuum and the outside environment. Now, logically, if a vacuum has a stronger fan, it would create more suction power, right? And this would also lead to better cleaning performance, right? Well, not exactly. So here's the catch. Suction power is only one part of the puzzle. There are actually several other factors that determine how well a robot vacuum actually performs. Things like the design of the air ducts, the size of the intake, and even the efficiency of the roller brush can dramatically influence the actual cleaning capabilities of a robot vacuum. And this is why we simply cannot compare just the suction power numbers and assume that one robot is better than the other just because it boasts a higher number. To help explain this, I've created 3 simplified models to demonstrate how suction power actually works in practice. We have model 1, model 2 and model 3. Let's call the model 2 in the middle our standard vacuum. In model 1, the intake is narrower, which increases the resistance to airflow. Now in model 3, the fan is more powerful, which creates the airflow capacity. Now comparing model 2 to model 1, we can see that model 1 will have less airflow due to the restricted intake. But according to Bernoulli's principle, as airflow decreases, vacuum pressure actually increases. This may sound a little complicated, but what it means is that model 1 could still create more suction due to its higher vacuum pressure, but that doesn't necessarily translate to better cleaning. Now when we compare model 2 and model 3, the difference is clear. Model 3 has a stronger fan and better airflow, leading to superior cleaning performance. This is where suction power and airflow come together, and we see the positive impact of a stronger fan. So in a nutshell, suction power is just one puzzle piece of the equation, but it is not the full picture. There is much more to it, like airflow and vacuum pressure, that will determine how well a robot vacuum can clean. And here's a quick summary of our models. Model 1, low airflow, weak fan, of course, it's poor cleaning. Model 2, we have moderate airflow and a weak fan, which equals to average cleaning. And Model 3, we have airflow as well as a strong fan, which is best for cleaning. This will give us the best results without a doubt. So from this, we can conclude that suction power alone isn't the best way to rate or judge a vacuum's cleaning performance. Here is where things get scientific. The cleaning efficacy, CE, of a robot vacuum can be described by this formula right here. CE equals Q plus P, where CE stands for cleaning efficacy or how well the vacuum cleans, Q represents the airflow, and P represents the vacuum pressure. And this formula is key to understanding robot vacuums and how their suction power actually contributes to the cleaning performance. So it is clear to see that the higher the Q and P values are, the better the CE ratio will be. And there is one company that seems to have really understood this balance is ECOVACS, a definitive leader in the robot vacuum industry, and their latest model, the T50 Max Pro Omni, is a great example of how to optimize both airflow and vacuum pressure for the best cleaning results. ECOVACS decided to just stop fighting this endless, mindless battle of just boosting the suction power. Instead, they focused on maximizing the airflow while keeping the vacuum pressure at a reasonable level. And their T50 Max model delivers a staggering vacuum pressure of 18.5 kPa, which was found to be the optimal value through extensive testing. And to boost the airflow, ECOVACS increased the size of the intake and also added a high torque fan that is not only powerful, but also much quieter than traditional fans. This new fan in here pushes 16.3 liters of air per second, thanks to the use of a 100 watts motor and a 6400 milliamp hour battery that can easily handle the increased power demands. And ECOVACS calls this brand new technology BLAST, which stands for Boosted Large Airflow Suction Technology. And according to their testing, this system can increase carpet dust removal efficiency by up to 80%. So when it comes to robot vacuums, don't just fall for the high suction power numbers. There is much more to the story, as you just heard. Only the right combination of airflow, vacuum pressure and design will make a definitive difference in terms of cleaning efficiency. And ECOVACS with the T50 Max Pro Omni is a prime example of this innovative approach. Choosing the right robot vacuum can be tricky, especially when manufacturers throw around crazy numbers like suction power and mopping pressure, i.e. the usual marketing BS. But if you take a more scientific approach and consider airflow as well as vacuum pressure, you will have a much better understanding of what's actually going on under the hood. And that's also why companies like ECOVACS deserve credit for pushing the industry forwards in the right direction with smarter and more effective cleaning technology. So if you're in the market for a robot vacuum, then consider opting for a well-established brand that's also transparent about the tech inside of their products. This right here is a cutting edge when it gets to the right combination of suction power, airflow, and the right airflow intake design and all of the ducts inside here. We're talking a world's first innovation. With the T50 Max Pro Omni, you will get a vastly increased efficiency without any additional noise. It's in fact even quieter than most of the competition. It is a genius, a brand new, never before seen concept with an epic name. As I said, it's called BLAST. And aside from the mind-melting power upgrade, it also features the newest tech when it gets to the path planning, to the navigation and customization, and you can set it all up to the T inside of an amazing dedicated app. And thanks to the True Edge 2.0, it is also a floor mopping pro with a dynamically extending mop to maximize the coverage at edges and corners. In addition, the side brush right here can also automatically extend and flare out to reach even the blind spots on internal corners to achieve a 100% cleaning coverage of all your floors. And one last time to hammer home this point, truly effective vacuum is only achieved when you maximize both the airflow as well as the suction power. And the T50 Max Pro Omni is maximize airflow and hyper suction power, and also a definitely drippy. So check out all the product links in the description. I will list and link the best deals for you. But before you go, smash that like button, then subscribe, ring the bell and click all to never miss amazing tech magnet videos. That's it for this one, and enjoy your day and I will see you soon.